Okay, let's check out 4.1 through 4.3 review. We did these two questions in class, though I think I should go over one more time question 2. The question's asking if these two triangles are similar, and to give the similarity ratio if they are similar, which is just the scale factor. So what we have to do is look at which segments are corresponding, like which sides are corresponding. So the shortest sides I highlighted in green, the next shortest in purple, and then finally the longest in blue. And the idea here is we know that if two objects are similar, we know their corresponding sides are proportional. So here I have 39 and 26. And what I'll do is take 39 divided by 26, and this should be equal, if they're similar, to 36, this length here, over 24, which should be equal to 15 divided by 10. Now if you wanted to, you can just type all of these into the calculator, and if you get the same number for all of them, then you know that all corresponding sides are proportional. I like to take a moment to find any way to reduce these. For example, if I look at this first ratio, 39 to 26, I know that those are both divisible by 13. If I divide the top by 13, I get 3. The bottom by 13, I get 2. Here, looking at this, I know that those are both divisible by 12. So 36 divided by 12 is 3. 24 divided by 12 is 2. And then finally, with this last ratio here, both are divisible by 5. So I divide the top by 5, I get 3. The bottom by 5, I get 2. So look, they're all 3 halves, or 1.5. Therefore, they're similar. And this would actually be the scale factor if we're going from the small triangle to the big triangle. Let's look at number 3. This says if the coordinates of L are 4, 3, and the coordinates of M are 4, 7.25, so let's plot those. They're telling us they're similar in the first place. And M is at 4, 7.25. So what we could do here is look at the length of LM and the length of EF. The length of EF is 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8.5. So we have 8.5. And then here this length is 1, 2, 3, 4, 4.25. Okay, so let's see. All we really need to do is say, okay, well, the ratio from 8.5 to 4.25, well, that's just 2. So then let's look at the length of EG. No, it's 1, 2, 3, 4, 5, 6. So if this is 6, then this must be half the length of that, which would be 3. 1, 2, 3. Since they're similar, we know that their corresponding side lengths are proportional. So we know that N right here is located 3 units to the right of L, and L is at 4, 3. So N is located at 7, 3, right here. Okay, let's look at this problem. we also did in class. It's wondering what the scale factor is. Well, we're looking at ABC as the preimage, so it starts with the big one. And then we're going down to the small one, ART. Then we know that the scale factor is going to be less than 1 because the dilation is getting smaller. Now, if you look at the distance from A to R, you can tell going from 0.8 down to 0.3, this should be 5 units. So AR is 5 units. And then you need to look at AB, its corresponding side. From 0.0 all the way up to 0.8, we're going 8 units. So once again, this is the image divided by the pre-image to give us our scale factor. K is our scale factor. We get 5/8. Alright, we have time for question 5. You can see here that if you look at D and D prime, see how they're closer together than B and B prime? It's an indicator that these have been reflected. There's been a reflection here. It looks like it's not quite at the y-axis, but perhaps it was at the y-axis dilated. This is irrelevant to what the question's asking. It says, are the two pentagons similar? So the question also refers to the angle measures. If you count all these up, 90 plus 90 plus 125 plus 120, you find that this should be 115 and this should be 125. So we know corresponding angles are congruent. We just need to check corresponding side lengths. So match these up. From C to D corresponds with C prime to D prime. B prime to C prime corresponds to B and C. These correspond, and these correspond, and these correspond. So again, if two figures are similar, then corresponding side lengths are proportional. So what we can do is start out with 4.95 divided by 3.3. And this should be equal to 3.6 divided by 2.4, which should be equal to 6 divided by 4, which is the same as 6 divided by 4 if you do the blue sides. And then finally we can do 7.5 divided by 5. We just need to check to make sure these are all equal. So if you plug that into your calculator, see if this will get it right. It's not reading it. 4.95 divided by 3.3. There we go. Get 1.5. So 3/2. 3.6 divided by 2.4. That should also be 3/2. Let's double check. Yep. This is 3/2. And then this should be 3/2. Or 1.5. So if you plug it in your calculator, you'll probably get 1.5 is equal to 1.5 is equal to 1.5 is equal to 1.5. Therefore, you know that these two pentagons are similar because corresponding side lengths are proportional.